This week in IT SPARC Cast, RAMBO is your air-gapped network's worst nightmare. Oracle goes nuclear, and John finds out that ActiveX is still a thing. Greetings and welcome to IT SPARC Cast. I'm your host, John Barger.
And I'm your host, Lou Schmidt. Let's go see what's going on out there.
It's Friday, September 13th, and it's your lucky day because IT SPARC Cast is a digest of the IT news from the last week with insights, opinions, and a little sarcasm from two engineers with over 20 years of experience in IT or working for IT vendors. And now the news bites.
Just when you thought it was safe to go back into your air-gapped networks, here comes RAMBO. This new RAMBO attack uses RAM radio signals to steal from air-gapped networks. So this was discovered by a researcher out of Israel, Dr. Guri, and this individual makes a study of breaking into networks this way. This is how it works. You have to compromise the network, whether you have an inside actor or you've got a poisoned USB key, whatever. But if you can get into this, and as we've seen throughout the world and technologies that are state-sponsored, somebody's going to get in, then this thing can look for the data that it's been programmed to look for, modulate it into your RAM. You can pick it up using a software-defined radio away from the site. That's always been the problem with breaking into air-gapped networks. Yes, you can break in via some sort of poison, but how do you get the data back out again? And this one solved it. So anybody who's ever been looked into this for a while knows about Van Eyck freaking, the concept of picking up these remote signals from the computers. Those of us of a certain age that were in the military certainly know about Tempest, which is all about emissions. Now it's all MCON type stuff, emissions control. So that is a thing now.
It is, it just always amazes me that the different vectors on attacks, and you think it's just some guy behind a keyboard, in the dark of night, but then something like this comes around, and it's just like one of those things that is, it's almost like the magical box you put next to a computer and it steals all its data. Sometimes that stuff's real.
Everything old is new again. Van Eyck freaking's been around for a long time, and it's going to be a long time. I mean, we're clocking at incredibly high data rates here. You're going R88. Absolutely. So that's really interesting stuff.
It is. Computer World reports that Microsoft will be disabling ActiveX coming later this year in Office 2024. So for those of you who aren't aware, ActiveX was launched in 1996. It was a framework to allow for interactive elements in your web browser and Office documents and things like that. This is just one of several steps that Microsoft's taken. They're taking multiple steps to improve the security of Office. For example, macros and extensions have been blocked. And later this year, they're going to phase out VB script. Now, Lou, I got to say, when I read this, I was like, ActiveX was a blast from the past. It's like, hearing somebody talk about a band from the 70s or something that hasn't been heard of since then. Little known detail, back in the 90s, I was co-founder of a startup that made a video player back before that was really a thing. And that was how we had to make the plugins for Internet Explorer back then, was an ActiveX plugin. And so just like complete wave of nostalgia for me that this is even still a thing.
I mean, it's still there. That's the thing, right? Are people actually, so I got to ask you, our listeners, are you actually using ActiveX? Are you going to notice this?
Or did you even know what ActiveX was? I never even heard of it. So, all right. Now, Lou's got a story about Oracle.
Oh man, you know that things are going to get good when Oracle goes nuclear, but this time it's different. So Oracle, and I'm not just talking Oracle as a company, I'm talking Larry Ellison, in an investor call, dropped the concept of designing next generation data centers with attached nuclear power. So the article comes to us by way of, and here
CNBC.
It's CNBC. Thank you. You get windows up all over the place when you do this thing.
Absolutely.
But they called it bizarre and crazy. Maybe not. We've seen a lot of disruption in the power grid recently because we're trying to shift to greener sources. The challenge with shifting to greener sources is, yeah, you can get a lot of energy out of solar and wind, but it's intermittent. So you got to back it up with some other stuff like batteries.
Well, there's also vulnerabilities from attack on the power grid as well, and we found that like what's happened recently in Texas, where the power is very variable, and they have to do, or in California they do rolling outages and things like that. So it's just like it's becoming more of a thing to be self-sufficient is important. I mean, this isn't new as a concept. I know that as far back as 2016, I was hearing about large data centers talking about implementing their own small modular nuclear reactors. But it sounds now like Oracle's actually getting serious about this.
It might be because at this point, they've already broken ground on some of the new small reactors from the Bill Gates backed company. They have something called a natrium reactor, which is a fast sodium reactor. What's cool about those is they don't breed plutonium. They burn things, burn being the specific term in this, more completely, and they can be built really small. They're sodium cooled. They're intrinsically physics safe, right? If you lose power, they're not going to go like that. So now we're seeing a situation where the power demands for AI and some of the next generation cloud technologies are so high that it might actually make sense. And the reason that we like to bring this stuff up is, guess who they're going to go bug about the power requirements?
IT department.
Yes. The person that always gets the phone call if something gets weird.
Right. So it's interesting. I went back and reread a few articles about this, kind of going back to what I had heard from the years ago. And I mean, there's a lot of things that make sense here. A small modular nuclear reactor, or actually in this case, they'll use 3, so they have some redundancy. It's got a lot of benefits. One is you're self-sufficient. Everybody else around you can be blacked out. You still have power. They're relatively easy to run, and and despite the stigma, they're fairly safe. And it's not that you're at a significant risk of a 3 Mile Island level meltdown or a Chernobyl level meltdown. These are relatively safe. Now, that being said, they're expensive to build. There's lots of regulations around it. You got to get a local approval. There's all these things you have to go through. But if you can get through all of that, and somebody like Oracle is going to have the cloud to push that through, then this might be something that we start seeing more and more of.
Think about it right now. Right now, a lot of the data centers are being pushed out to where there's power, which is why you see things, a lot of data centers, the Pacific Northwest. You have the Columbia River, and you've got a whole pile of wind power out there. Power is cheap. So people build data centers there. I don't expect to see this in the middle of New York City or Chicago. I expect to see this in a remote location with a decent amount of cooling available. But, as per your point, John, the second safest source of power is nuclear. Solar is the first, and only if you don't factor in installers falling off the roof. If you factor in installers falling off the roof, nuclear is actually safer.
That's so
great. Yeah, it's this is one we're going to keep an eye on, see if anybody actually really pushes this through. But talking about end-to-end in your infrastructure, there's more than just power that you're worried about. In fact, there's stuff that you're much more worried about. John, I think you have something to address that.
Yeah. So according to TechCrunch, a company called Odigos, I think I'm pronouncing that right, it's Odigos, is helping enterprises detect system errors and reduce latency through various observation solutions. They are, this is a Y Combinator-backed startup. Their platform allows for the automation and integration of observability tools. And they're doing it in a unique way, whereas this is observability inside the system itself. And they're using a technology called extended Berkeley Packet Filters, or eBPF. Now, we're going to talk a little bit more about that technology later. We're going to do a deep dive on it. But this is going to allow for a level of scale and high performance monitoring and system improvements that would not be possible without this type of tool. So something that we're going to be keeping an eye on as they start to roll it out. But again, automation, reducing human errors, and being able to figure out your performance optimizations to get your systems running just right sounds pretty exciting.
It does. And let's face it, we're living in a cloud world now. Right. Container-based technologies, cloud deployed services, even within your own data center, you're probably going to scale out this way. And how you track what each container or component is doing is turning out to be really, really important. Traditional tools aren't up to the job.
That's right. I think that's absolutely right.
So as your footprint expands into this hybrid world we live in, I think ultimately, Lou's personal opinion, is that we're going to end up in a halfway state where things are cloud deployed and locally deployed, especially as the power of local processing becomes cheaper and cheaper. But it's always been a balance. The idea is, how do you know where to put the workload, and how do you know what the workload is doing? And this has a tremendous amount of potential.
Love it. I love it.
And now it's time for your Friday the 13th CVE of the week.
That's right. So CVE of the week is our weekly segment where we pick a common vulnerability and exposure entry that you need to know about and mitigate ASAP. So what we have here is yet another Windows flaw. This is tagged as CVE 2024-43491. It's marked as actively exploited. So there are exploits in the field, and it's a critical case that carries a CVSS severity score of 9.8 out of 10. So I'm going to read directly from the Microsoft bulletin. It says Microsoft is aware of a vulnerability in servicing stack that has rolled back the fixes for some vulnerabilities affecting optional components on Windows 10 version 15.07. This was something that was initially released in July of 2015. So it is an older version of Windows, and newer versions are not susceptible to this. But what it means is that an attacker is able to roll back patches and then attack those those now unpatched flaws. So this is again, an older version of Windows 10, but the impact can be very dramatic. So a patch comes out, gets rolled out, they roll it back, and then they come in and attack that way. Microsoft didn't provide any information about those public exploits, or they didn't release any indicators of compromise. But we do know that there are exploits out there. Now, again, I said this is an older version of Windows, but so far this year, Microsoft has acknowledged 21 zero-day attacks that exploit flaws in the Windows ecosystem. What do you think, Lou? Is this something that we really need to be concerned about, considering how old the OS is?
Oh yeah. Come on. How many of our listeners out there are still running Windows 10? How many of them are still running Windows 7? Look, John and I were talking about this before we queued up to record. There was a case about 8 years ago where a particular sub-brand of a homebrewed BGP router that was being used by service providers up in the Baltics triggered a BGP update error that had been patched by Cisco 2 to 3 years before this incident happened. And it still took down a quarter of the internet, right? So we know, look, you've got code that's running, you think it's isolated, you're still going to run it, especially common in industrial applications where you think security by obscurity is going to save you. I mean, we've both seen old code all over the place.
Yeah, so we want to hear from you. So are you still running Windows 10 in your enterprise environment? And if so, why haven't you updated all your systems to Windows 11? Is it budget? Is it that you have a compatibility issue or whatever? So send us a note at feedback@itsparkcast.com, or we're also at IT SPARC Cast on X. So now for this week, we're taking a break from our discussion around remote work and how IT can improve the remote workers' experience so that we can introduce a new segment, Lou's Hot Take.
Oh my God. They're going to let me be a geek on camera. And this one's horrible. Not that we aren't going to go back to talk into the remote access a lot more, because we've got a huge amount of things to say there. But we have had a great opening when we talked about that new startup. How do you monitor this stuff? And this really does factor into everything you do, because your remote workers are going to be, you've got to figure out how your communication systems are working. So let's talk about eBPF, the extended Berkeley Packet Filter. So let me give you a little background before we really kick this thing off. Everybody here saw what CrowdStrike did. Now, CrowdStrike did not set out to be malicious. This is not something that you go, oh, ha, 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 CrowdStrike, right? Things happen. Things happen to all of us. And there will be errors like this all the time. And it just so happened that CrowdStrike hit a nasty one, right? For embedded systems that were less easy to get to, that had less backup from the perspective of watchdog timers and stuff to back out a change that had caused a failure. So what are we going to do about this? Microsoft right now is looking, they've publicly said they're looking into a way to disintermediate having folks get directly into the kernel to do these type of security updates that will not impact performance. What if there was something out there that can already do this? Well, the answer is there is, and it's called Extended Berkeley Packet Filter. And it is a Linux function right now. Microsoft started a project in 2022, so there's an open source Microsoft project you can get to implement eBPF in the Windows kernel. I haven't actually checked that recently. I know a lot about eBPF within the Linux kernel, but let's face it, if you're in the cloud, you're on infrastructure, your switches are running Linux, your router is running Linux, your cloud is running Linux. Chances are you're in Kubernetes all over the place. You may not even know it. And this technology is really great. So, you know, what problem, why should you care? What problem are we solving here? When you get in to do high performance packet analysis, high performance process analysis, tracings, particular process connections, looking at certain memory locations, you have to do it in a privileged manner. You have to be in there as root or admin on a Windows system. And that is where you have the potential to really have some challenges. Also, the challenge is, how do you bring monitoring tools into an environment when that environment could be updated? Linux kernel sees updates all the time. And getting a change into that kernel is doable, but sometimes it's a challenge. And even getting it in there, getting it past the Linux kernel maintainers and then out into wide distribution is an issue. What if there was a way for you to compile bytecode, check to make sure it was okay, deploy it directly into kernel space without monkeying with other programs? And that answer is eBPF. So what is it? Essentially, think of it this way. It's a just-in-time compiler that sits between kernel space and user space. And kernel space, John, we were talking about this earlier. Do you want to give us a little more color on the difference between kernel space and user space?
Yeah, so smartly, most operating systems today do divide themselves up between what's called kernel space and user space. So kernel space is the very core of the operating system. That's what kernel means. And the fact you're running basically as full level control system god over the system. You have complete access to the hardware. You have no layer of abstract extraction from that hardware, and allows you to run both at high speed and with direct access to those resources. User space is fully abstracted from that. You actually have to talk into the kernel and request access to the network cards and to memory and to disk space and so forth. And based on your privileges, you get or don't get access to some of those things. But again, it's all through that layer of abstraction. And you could say that an administrator has access to be able to delete files and maybe read what's going on the network, but a user only has access to maybe read some files and not write to them or not delete them, or only can delete their own personal documents and so forth. So just, and most of our listeners already understand this, but just to clarify, Lou did mention root and admin access. Kernel space is different than having root or admin level access. Kernel space is direct access to the hardware, whereas being root or admin is still going through the kernel. And a lot of times you have to authenticate again, even if you're logged in as root, in order to get something done. And there will still be gates in place, even with that elevated privilege.
Not only that, but there are some functions you probably can't even do. And what eBPF gets us is that shim layer between the kernel and user space that has guardrails. It can read memory locations. It can redirect packet traffic around the kernel, actually. You can write an eBPF driver that runs directly on an offload, a TOE card, TCP offload engine card, and bypasses the kernel completely. So if you're doing a lot of network operations, that's really helpful. The cool thing about this is that it is a stable API. Like Java to a browser, you can write eBPF directly to a kernel. And while a newer kernel might introduce more features, it should not break the stuff that was already there. And that was the source of a recent rant from Linus Torvald on the kernel list. I think you have something you want to say, John.
Well, yeah, I wanted to go back to the CrowdStrike issue, and I'm not trying to harp on that, but it's just the most recent, massive issue that came out of this. But the reason that CrowdStrike and other tasks are integrated into the kernel, they launch, that's because they launch before any user space code, before there's any authentication, and they can even run in Windows safe mode if it's in Windows, so that it's always running and they always have the ability to do whatever it is that they're supposed to do. But that also brings risk with it, in that if there's a flaw there, as we saw with CrowdStrike, then they're going to continually have that problem, and you may not be able to get out of it. But without running directly in kernel mode, can these tasks actually be effective at doing their job in protecting the system?
No. You need a high level of access. So what eBPF does, let's talk about what it's actually doing.
Sure.
Right? It's so historically the operating system's always been, you're going to be in the operating system to get access to that low level information to mitigate real-time threats, look at real-time performance, real-time tracing, all the stuff we need in our further distributed world. And fortunately, as I mentioned earlier, we have a huge base of devices out there that can handle this technology. So basically what it does, it's going to give you a sandbox to run within the operating system directly, which means application developers can run eBPF programs, add additional capabilities to the operating system at runtime. So the operating system guarantees the safety and execution efficiency as if natively compiled with the aid of a just-in-time status. So this would be like you compiled a new kernel and added this feature, except you did it in real time. And you didn't have to run it through a whole bunch of other process. Now, we will address the downsides of that, absolutely. So it gives you that. And so the system privilege shim, it runs natively. So you can get the kernel code, and kernel modules there's other ways you could do this. One, you can modify the kernel. We talked about that. Two, you could build a kernel module. The problem with building a kernel module is A, either you've got to get everybody to accept it and propagate through the system. B, you got to maintain it. And C, somebody could come along and break it. Now, once again, back to the earlier Linus rant, that's bad behavior, but it does happen. So you get and these programs that you put in are event driven. You put in hooks in the kernel that allow you to see an event happen and do something. Now, obviously, if you're a network geek like John and I are for the most part, I would say, oh, I saw a packet that needs to be looked at, needs to be teed, needs to be dropped, needs to be rewritten. I can do that incredibly efficiently, very, very quickly with minimal kernel overhead with this, but I can do much, much more, which is why Microsoft is looking into this.
Well, so you say you can do a lot more. What kind of things can we do? What is this going to allow us to do that we would normally have to do right in a kernel?
Well, there's a whole bunch of open sources projects out there that are leveraging eBPF to ease analysis and monitoring. Also, there's native toolkits available that make it so that you don't have to write directly to it, that you can hit a toolkit. These are all open source. And they've kind of gone to the open source with support model on a lot of this stuff for enterprise. So often enterprise support is available. And so let's talk about some of the stuff that's out there. There's something called Falco. Falco is a cloud native security tool designed for Linux systems. Anybody who's been watching the container space knows that security is a bit of a challenge. Getting a standardized method of security. There aren't really firewalls that run in containers. Now we're starting to see that happen. eBPF is a critical component to allow that to happen. There's something called Core Lab, so monitoring system containerized components. These things can actually map them in real time and show you where the flows are going. Deepflow.io, doing full service. Once again, another open source component that offers premium level support. And then there's sort of the granddaddy of them all, which is Cilium. Cilium is maintained by the same folks who are driving eBPF at the kernel level. As you know, in the open source community, we have a lot of folks that are driving enterprise products that are from enterprise organizations, major kernel contributors like eBay, Google, little companies like Microsoft and Amazon, IBM, all over the kernel. If you guys read kernel comments, if you have no life and you've compiled kernels on your
own. So with tools like Falco and Deepflow and Cilium, this is going to solve all of our problems, right? Everything's going to be hunky-dory going forward.
Well, let us once again wander back to CrowdStrike, who in March pushed out I believe they were using Falco, pushed out an update and managed to cause a kernel panic in Red Hat. So this is more of we're on the right path than it is we've solved all the problems. There was a really great article on this as far as what the potential problems are. By way of Security Boulevard, something came. There are risks associated because eBPF still can compile at a root level, right? You still have to be a privileged user to bring this code in. The way I like to look at it, and John, of course, is well versed with this one, is if I give you the ability to shoot for the stars, I also have to give you the ability to shoot your foot off. Yes, you can. You can cause a kernel panic, but my hot take on this is that I think this is a good way forward. This is a good way forward for us because it presents a very systematic method of accessing this code, of distributing stuff further into the operating system or further into, say, specially adapted access cards without having to hammer on kernel developers to try to get a driver done. You can do this all yourself. Also, it's a very high priority for the security and the kernel community within Linux, which means when stuff is found, it's going to get fixed. So the big wild card right now is Microsoft going to go in this direction? And we should be getting an answer to that probably in the next couple of weeks. And we're definitely going to keep an eye on it for you. But I would urge you, if you have some Linux systems handy, and I think we all do, to take a look at this. There's a whole bunch of online demos. If you go to the Cilium page or the eBPF page, if you just do a quick search, you will find tons of applications for this with real-time demos and stuff code you can download and try it yourself. Take a look at it. There's a low barrier to entry here.
Yeah, no, so I think it'd be really interesting to see what Microsoft does. So we know that a few years ago, Microsoft was looking at the eBPF framework and seeing what they could do with it. We also know that they recently announced that they're putting steps in place to prevent the next CrowdStrike level failure. We don't know what that is yet. We were going to put that in the quick hits, the news bites earlier, but we just didn't have enough information to really go into that. So we'll be keeping an eye on this, and we'll be reporting out to you on what's coming from Microsoft. Is it going to be eBPF? Is it going to be something else? And what are the other things that we can do? But hey, Lou, I thought that was a great overview. I learned a lot. I didn't know much about eBPF before we started this. So I really want to thank you for going over that. I want to thank all of you for listening. We're going to be wrapping up today's episode. But what do you think? Is eBPF a valid alternative to running directly in kernel space? Would this have lessened the impacts of that Windows CrowdStrike issue? Is there an alternative, something that you think would actually be a better solution across the board, whether it's Linux, Windows, or what have you, to be able to accomplish what is necessary through those security tools, but without providing the potential compromise? Or just in general, are there any other topics you want us to cover? Send us email at feedback@itsparkcast.com, or you can hit us at @ITSparkcast on X. And again, that is ITSPARCCAST in both cases. Be sure to hit like and subscribe, turn on notifications if you're on YouTube. That's really going to help us grow and get to a greater audience. But with that, we're going to wrap up this episode. We'll be back next week with more news and opinions from the world of enterprise IT. Take care.
Thanks for coming by.